The light enters through a hole in the sky, 27 feet in diameter, a perfect circle cut from the dome's apex, open to weather, sun, rain that falls on marble and drains through channels so precise the water vanishes before it pools. The dome above, the largest unreinforced concrete dome in history. 142 feet from floor to summit, 142 feet of span. Same dimension for height and diameter, making the interior a perfect sphere. A ball 142 feet across would sit inside the Pantheon, touching floor and dome simultaneously. No one has built larger since 1,900 years. Not because engineers haven't tried, because the material science to exceed it without steel reinforcement has never been duplicated. If the secrets behind the largest unreinforced concrete dome in history fascinate you, subscribe now. The 5 recipes this engineer is about to reveal have kept a building standing for nearly 2,000 years. I know why. I know what's in the concrete. Not one recipe, 5. Changing as the dome rises from base to crown, each layer using different aggregate to manage the single force that would destroy any uniform structure at this span: weight. The dome weighs approximately 5,000 tons. Supported only by itself, no skeleton, no reinforcement, no internal framework, the concrete must bear its own weight while resisting outward thrust pushing walls apart and compressive force crushing the crown. A dome equals an arch rotated in a circle. At the base, forces push outward. At the crown, forces compress downward. Uniform material cannot handle both. Heavy enough for the crown equals too heavy at the base. The solution: not new engineering, new concrete. 5 opus cementitium variations, each tailored to position. Heavy at the base, light at the crown. Gradiated transition. This is what I do. The architect draws lines. The foreman organizes labor. The material, the substance that makes the impossible possible, comes from my hands, my formulas, my knowledge of aggregate and lime and ash. Let me show you the recipe for eternity. 5 layers, 5 recipes, same binder, lime and pozzolana, but different aggregate, changing density from 2,300 kilograms per cubic meter at base to 1,300 at crown. Layer 1, foundation ring, floor to first cornice, 21 feet. Aggregate, travertine and basalt, heaviest. Dense, strong, bearing the compressive load of everything above. Construction grade, same as harbor breakwaters. Layer 2, lower dome, 21 to 50 feet. Tufa and broken brick, lighter. Tufa, soft volcanic rock, porous, lets lime grip the surface. Broken brick equals angular fragments interlocking within the matrix.
Layer 2 mix, 2 parts pozzolana, 1 part lime, 4 parts tufa. Wet the aggregate first. Dry tufa drinks the water from the lime before it sets. If the tufa absorbs mixing water, your concrete is dry and worthless.
The pozzolana, volcanic ash from Pozzuoli near Vesuvius. Gray powder that reacts with lime and water to form calcium-aluminium silicate crystals. Waterproof, grows stronger over time. The chemistry. Reactive silica and alumina in amorphous state, molecules disordered, available. Mixed with lime, calcium hydroxide, plus water, yields dissolve, yields recombine into new crystal structures. This pozzolanic reaction continues for decades. Roman concrete gets stronger with age. Layer 3, 50 to 90 feet. Transition zone. Small tufa plus hollow clay pots. Empty ceramic vessels, sealed, creating voids that reduce weight without reducing structure. Light, strong in compression, enclosed by the matrix. Layer 4, 90 to 120 feet. Volcanic scoria, porous rock full of gas bubbles. A cubic foot weighs less than half a cubic foot of basalt. Layer 5, the final ring around the oculus. Pumice, so light it floats on water. The concrete here weighs half the foundation concrete. The dome's crown is held by one of the lightest structural materials in the ancient world. The centering, the scaffold holding wet concrete, is a timber hemisphere, 142 feet, filling the rotunda. Oak ribs, pine planking, approximately 6,000 tons of temporary load. Building it equals a major project. The timber must support wet concrete, ribs 12 inches square, planking 2 inches thick, internal compression rings, horizontal timber circles resisting inward collapse. The pour begins at the base. Layer 1 mixed on the ground, carried up in bucket chains packed into formwork. Each ring poured continuously. Cannot stop once started. The lime must bond. Speed matters. Pozzolanic reaction begins on contact. Initial set, approximately 4 hours. Concrete must be placed, compacted, leveled in that window. Full strength, weeks to months as the crystal matrix grows. When the sintering starts groaning under 5,000 tons of concrete, timber compressed, joints creaking, bracing rings bowing, the question becomes whether dead wood can hold long enough for living chemistry to take over. Subscribe. The answer defined Rome. 24-hour operations during pours. Night shifts by torchlight, mixing floors lit by braziers, laborers climbing by firelight.
Layer 3, scoria aggregate, not tufa. We're past the 50-foot line. Wrong aggregate above this point, and the dome is too heavy. Check your buckets before you climb.
The coffers. 5 rows of recessed panels, 28 per row. Art historians call them decorative. They're structural weight reduction. Each coffer reduces volume, deepest at mid-zone where weight reduction most affects base thrust. Near the crown, pumice equals already light, shallower. Step rings on the exterior, 7 concentric like a wedding cake, each thinner than below. Reduce weight progressively plus drain rainwater in stages. The pour, approximately 3 years. Continuous concrete work, mixing, hauling, placing. The centering carries growing load. Lower layers already strengthening via pozzolanic reaction, while upper layers are being placed. The centering groans. 3 years of increasing load. Timber compressed, joints creaking. Designed to be temporary, carrying 5,000 tons with the patient suffering of a structure that knows its own death is the dome's birth. Centering removed from the top. The oculus ring, pumice aggregate, lightest, freed first. It holds, bears its own weight and nothing above. Ring by ring descending. At each stage, the dome transfers load into concrete below. Compressive forces channeling through the curve. Outward forces absorbed by walls. The structure finding equilibrium section by section. As timber comes down, the interior opens. Hemisphere of concrete revealed, coffered surface emerging, the curve rising in mathematical perfection toward the sky. Final timber removed. The dome stands alone. 5,000 tons of graduated concrete, supported by geometry and chemistry. No framework, no reinforcement. Pozzolana, lime, stone. Arranged by a mind that understood material the way a musician understands sound. Light enters through the oculus, a solid column of sunlight pouring through the 27-foot opening, striking marble with intensity that makes the interior glow. The beam moves with the sun, eastern niches in morning, floor at noon, western wall in afternoon. Tradition, pozzolana and lime, 200 years old. Every engineer knows it. Every harbor, aqueduct, foundation uses the same binder. The progress is not in the new, it's in the understanding. 5 variations of a traditional material, arranged by insight that weight is enemy and gradient is weapon. This is tradition deeply understood, not repetition. The deep knowledge of a material, chemistry, limits, possibilities, allowing extension beyond anything the inventors imagined. The dome has stood 1,900 years. Earthquakes, floods, barbarian occupation, papal conversion, the concrete is sound. The pozzolanic reaction, still proceeding, has made it stronger than the day it was poured. No one has built larger since, not because they haven't tried, because steel reinforcement made graduating aggregate unnecessary. Modern domes use rebar, lighter, faster, cheaper. They crumble in 50 years. The Pantheon's concrete is still getting stronger. The light through the oculus touches the floor and moves on. Every day for nearly 2,000 years, the dome above, 5 recipes, 3 years, 1 idea, holds the sky open for Rome.